Hi there, welcome to this one-off tutorial where I want to explain a little bit about what a histogram is and what a distribution is, and when you're sampling or choosing from a distribution, how the histogram would affect that. So maybe you're totally new to statistics, or you're just not familiar, you spend a lot of time doing anything with histograms or random sampling or anything like that. And as I was making a retirement simulator tutorial series, I thought, wouldn't it be nice to have an extra explanation of what it means and how one goes about building a distribution from and how that corresponds to the histogram that we talk about. So I made something here. It's a really simple thing in Python that I made called a Histogram Builder. This is just for the plotting purposes, but it doesn't totally matter what this is, and if it does, then we'll get to that. But what we're going to do, I'm just going to open up this terminal, and I'm going to import the thing that I made. And I'm going to import it this way, from histogram _ builder import well, I'm going to say histogram _ builder as HB. Okay, and perfect. It did that on screen and everything. So what it did there is it imported my histogram builder, and then when it filled it, each with one entry from 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so this is our sample histogram right now, and it's just got one. It's a list of numbers that's been plotted with these bins that are 1 unit wide, and we see that this bin from 0 to 1 has nothing in it because the value 1 goes into this upper bin here, and so on and so forth. So the value of 1 went into this bin, the value of 2 went into this bin, the value of 3, and so on up to 10. The value of 10 went into the bin that has the bin edge here right at 10. And so if I also say from histogram, now this is a personal thing that I made, so this is not any Python thing, but I can put this in the description below this little one-off tutorial so that you can see. I can say import get list, and then I say a list equals get list. So this is the list that I made, and if I show you a list, it's just the numbers I said, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and so what the histogram builder does is that as I import another number, if I wanted to add the number 5 to the histogram list, I could say, let's see, what would I call it? Oh, I'd say a list equals, this is just how it works, HB, which is what I imported it as, the number 5, and then I have to give it the list again. So when I do that, now we can see we added another entry here to the 5th histogram bin column. I'm going to do something, hopefully that works. I'm going to make this a little bit smaller, and I'm going to make this screen also a little smaller so you can see them both at the same time. Alright, so here's our terminal, here's our plot, and if I add another 5 to that, you can see that our plot will just continue to get bigger only in the 5 column. If I change it and I add a 10, suddenly we're growing over at the 10. Okay. Now what I want to do is I want to fill up this list with a bunch of 5s. And I'm going to do that just for the purpose of demonstrating something here. So we're going to say for I in range 100, a list equals HB 5, oops, not 54, a list. And that's it. And so now we're filling up our histogram with all these 5s. And you can see that our histogram now basically is consisting of a lot of entries of the number 5 and a lot of entries of, there's only a singular entry for 1, 2, 3, 4, 6, 7, 8, 9, and a few for 10. Okay? If we actually look at our list, you can see it's a list full of 5s with a few other numbers. Okay? When you sample from this list, what would you guess is the most likely number you would grab from this? Say that all these numbers were little strips of paper with that number written on it. You put them in a hat, you reach into the hat, what number are you going to pick out? Probably the number 5, right? And so we can sort of demonstrate that if we use the random class or module. So this is something that's in all the scientific pack. I think it's in the standard distribution of Python. So we say import random, and so in fact we'll say from random import choice, because that's the choice is what we want to use. Choice we'll take from a list. And we can look at that. We can say help choice, and it's a choose a random element from a non-empty sequence. And so what choice will do is it will extract a single element from whatever list you provide it, and we're going to provide it our list here. So that if we said choice from a list, chances are pretty good it's going to return the number 5. And if I do that many, many times, it's going to keep returning 5. But if I did it long enough, it would return a number that was not 5. And so we'll just do that for I in range 100. We'll say print choice a list. And you can see right there we had a 6. And we had a 10. We had a 1. Another 10. A 4. So we did get a few non-5 numbers from our list. But our list was pretty clearly skewed so that it would be the number 5. But now we can alter this distribution, right? So we could say for I in range 80, and we can say a list equals, we'll add the number 4, and then we'll do another one. A list equals 6. So we're going to, instead of adding it 100 times, we're going to add the numbers 4 and 6 80 times. And did that work? Anything here happening here? Oh, okay. Well, I just totally screwed up because of Python's ability to redefine stuff. I defined a list as a tuple 80 times instead of using that HB thing that we did. So I can try to if I just say a list now, it's just gonna, yeah, it looks really weird. Something terrible has happened. So we're just gonna start over. A list equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so there's our original list. And now if we say, a list equals, what we meant to do was HB, and then the number 5, and a list. So it's keeping this current window open, but it was replotting it. So yeah, this is what my program is kind of giving me right now. Okay, which is kind of funny, right? Okay, so if we said we can do that same trick again, we can say for I in range 80, and we don't have to give it 4 and 6. Why don't we give it a list equals, we'll say 2 and 7. Okay. So, you know, there it goes. Now we have something that you might, in some fantasy world, call a bimodal distribution. And again, you have a few instances of 1, 3, 4, 5, 6, 8, 9, and 10, but mostly you have instances of 2 and 7. So that if you said for I in range 100 print choice from a list. Yeah. It's going to be mostly printing 2 and 7, which it does, but it sometimes prints a 9 or a 5. And there's another 9 and a 3 is smuggled in there. So hopefully I've demonstrated to you now a couple of things. One, how to build a histogram, what it is. A histogram is a list of numbers that when plotted as a histogram will show up in these funny bins. And then two, when you sample from a list, you're just grabbing one item out of that list and using that, and it's a randomly selected one. But when your list is distributed such that most of the values in it are a singular value or a set of a certain number of values, that's the number you're most likely to choose. So I thank you for watching this little one-off on histograms and lists and sampling. And I hope you have walked away with a better understanding, especially if you're doing the retirement simulator series that I put out there. And if you're not doing that, then now's a good time to kick it off. All right, thanks for watching.